So we have another BmMT problem. So this was from 2024 and relay run. So this is a cool problem set. So we have like the set number 5, I guess. So 13 and 14 are related to each other in terms of the answers. So the first one we are given like line y equals and then y equals are given intersecting with this line at 2 different points, A and B, and then O is the origin. We are given the area of the triangle ABO as the answer to this question. Okay. And 14, like NO13 is the answer to the 13, so which is the area of the triangle and the number of ways to choose two positive integers a and b such that this inequality is satisfied. So like the question is somehow complicated, so make sure you really kind of understand before you look at the solution or even attempt yourself. So what I'm gonna do first, like let's kind of visualize this a bit to make it a bit sense of it. So we are given like a coordinate plane. Okay, so and then we are told there's like y equals something. So that let's say this is y equals root 2 over 2, and this is x and this is y. And there are like two lines, right? So the y equals something which goes through origin. So then I'm going to say, let's say this is one line. Then it doesn't really matter how that looks like in terms of which one is which. At least we know one slope is different from the other one. And let's say this is like A, and this is B, which you can solve if you want to. And I think it says A and B respectively, but in terms of the area, it doesn't matter. But so we are looking for the area of this triangle as the answer to the question 13. And that's what we're going to use. But how do we do that? Like we do have 2 points. I'm going to call, let's say this is x1, and this is x2 as x coordinate. So, the y coordinate has to be the same as this one. So which is going to be like root 2 over 2, and then root 2 over 2 as your y coordinates for this guy as well. Okay, so then the difference between the x value will be the AB, and then the height will be this distance, which is root 2 over 2. So the area, I'm going to say, will be like 1/2 times the root 2 over 2, which is my height, times the base, which is difference of the x's. I'm going to call that's like x1 minus x2. So we are told this is the answer to the question 13, which in the 14 says the n of 13 is the answer to the question 13, which means whatever we get from here is actually going to be n of 13. Okay, so that is something. But we kind of need to know this one. And then we never use this information, which means we probably want to use that. So like, this is a point going through one of these like lines. Let's say x1 maybe goes through this one, maybe x1, let's say, which one is x1? So this is like, I think I'm going to take this guy as x1 like this one. So this will be that one. Let's try that. So that it will be like x1 over 20 is equal to y, which is root 2 over 2. Then if I take the x2 for this guy, so that should be like x2 over 20 minus n of 14, which is going to be root 2 over 2. So like, since we know the difference of the x's, maybe we should get those in this equation. So if you multiply both sides by 20, you get x1 as 20 over 2, which is 10 times root 2. And then for this one, x2 will be like I can multiply this both side by this number, and then you will get root 2. Like I can cancel with 2, that will be root 2 as a denominator. So like you will get 20 minus n of 14. This is divided by just root 2. And if I clean this, like divide by like root 2, so that should be like 10 root 2 minus n 14 over root 2. Okay, this is kind of promising, but we want the x, like the difference of those x's, so that should be like x1 minus x2. So when you subtract this from this guy, the 10 root 2 will cancel, and then this will be positive, so you will get like n of 14 over root 2. Okay, so then I'm going to plug this into right here because that's basically equal to this one. So that should be like n of 14 over root 2. So then our next step, like, n of 13, which is my area, is equal to like root 2. Like this is n of 14 over root 2. This root 2 and this root 2 will cancel. And then you got like n of 14 over 4. And if I clear this a bit, so the n of 14 is equal to 4 times n of 13. Okay, so we got this, which is good, which is promising, which means one of the answers will be 4 times of the other one. Let's say we don't really get anything other than this one. Maybe we can go ahead and guess our n13 and kind of see if that's going to satisfy the second condition. So that might be another solution, like at this cheese whatever. But let's see what else we can do. So I'm gonna kind of clear this mess, but let's keep this in mind. So if 14 is 4 times of the 13, so n of 14 is going to be 4 times n of 13. Okay, so that is good. Now we have second part, like which is interestingly challenging looking because we have no numbers for AB and n of 13. So like whenever you have this kind of situation, it's good to like try finding the boundaries or extremes, right? So like I'll try like taking we know that A is lesser than or equal to B, and then A plus B is lesser than or equal to 2 times of n of 13. So if I kind of want to make some sort of the extreme, so I'm going to make a table. Okay, so let's say this is my table. So like we have like A and B. I'll take this as like A and this is B, and I'll take this as the smallest, and then this is the largest. So like A, like since we are interested in positive integer, and then A is smaller than B, so the smallest A has to be 1. And then B, like, A, largest A, can be at most B. They are equal to each other, but A cannot be larger than B. So which means the largest A should be our B. Okay. But what does that look like? Like maybe we can just write maybe this in terms of this. Like if A and B are equal, then that's 2A is equal to 2 times this 2's cancel. And then A or B is going to be equal to n of 13, which means we actually can write this guy as n of 13 because that's what we are trying to kind of get as our number. And so that means smallest A is 1 and the largest A is n of 13. So which is good. And for B, the smallest B is A. That's the smallest we can have. But the largest B is kind of slightly interesting. So like if you choose like A as equal to B, because they are equal to each other, and in some cases, right? That's the kind of the extreme. So then in that case, like our B is going to be 2 times this minus A. So if I subtract A from this inequality, so the largest one of like B in terms of A will be like 2 times n of the 13 minus A. Okay, so this is good, but now what? So like we have the like we want to kind of make it somehow one variable instead of two, right? So like we know that the smallest A, like smallest B is A, the largest B is this. So which means like if I remember this inequality, so for B, for example, the smallest B is A. So I'll say A is smaller than B, and this is smaller than or equal to 2 times n 13 minus A. Why do I care about that way? Because B now is in between two like expression that is in terms of A. So like just a reminder, like at this point, so like if I have, let's say, like 21, 22, all the way to the 49, for example, if I ask you how many numbers like in this list, there are a couple of ways, but one of the ways I will usually use 49, subtract whatever you are missing. So you're missing the like 20 numbers right here. So you can do that. But if I have something like this A plus 1 all the way to the B, then in total we have B numbers if you are increasing by 1, but the first A minus 1 number is missing. So if you subtract A minus 1 from that, so this is going to tell us number of terms in this sequence. So similar to this idea, we can say the number of B's. Okay, so the number of B's will be the last number, like this one. So 2 times n of 13 minus A. And then the previous term before A is A minus 1. We are going to subtract that from this, A minus 1. So the number of B's is going to be like 2 times n of 13. So like we have negative A, that's minus 2A, and then you got plus 1. So this is the number of like kind of different B's in terms of A. So which means if you start plugging A, like 1, 2, 3, whatever, all the way to the largest A, which is n of 13. So you will get all different B's. That will be basically going to be a number of like pairs, which is answer to what we are looking at. So based on this, we can actually write this in some notation instead of writing this kind of separately, because that will make it slightly easier to deal with. So then I'll just start with this. Okay, I'm going to say this is the number of B's, right? So 2 times n of 13 minus 2A plus 1. And then my A start with 1. And then the largest A was like n of 13. And this is what I'm going to simplify. So the first thing I kind of need to know, like when you have the coefficient, you can actually pull those. And then when you have addition subtraction, you can split this summation, which is okay. So then the first one is going to be like 2 times the sum of those numbers for n of 13 from A equals 1 to n of 13. And the second one has negative, so I'm going to take this negative 2 in front. So that should be like A starts 1 at ending at 13 again, n of 13. And the last one is plus 1. And the same thing for this one. So the first one we have like the meaning of this, you plug 1, that's equal to n of 13. Like imagine this is a constant number, right? So when this is 1, this is whatever that number. If this is 2, this is still the same thing. If this is like n of 13, this is the same thing, which means you're going to actually have this many times. So which is going to be equal to n of 13 times n of 13. So if that doesn't make sense, like change this number to something else, concrete value. Let's say this is 5, and then work with those. And then for this one, like when you plug A is 1, the value will be 1. If A is 2, that's 2, 3, 3. If A is n of 13, you got n of 13. So you're adding 1 through n of 13, which is just the Gauss for the first n of 13 numbers. So then I'll just say this is going to be equal to negative 2 times n of 13 times n of 13 plus 1 all over divided by 2. And the last one, you always get 1, so this many times, so that should be n of 13. So when you clean this mess, when you multiply this by this, you get n13 squared, but you already have this one as well. But I think we have 2 right here. So this is 2 times this. When you take the one of them, you will get only one of them left over. So that should be n of 13 squared. And then now you have like n of 13 times 1 with negative, that's minus, but this is plus, they will cancel. This is equal to that. But what is this equal to? This is the number of like pairs, which is the number of ways to choose 2 positive A and B. What is that? It says N of 14 is equal to answer to 14, which means this is my answer to this question, and we are told this is equal to N of 14. Okay, so again, make sure you're convinced with that. So then this is what we have from the second problem, and then this was what we had. So now we can just combine these to get what we really want to get. Okay, so the final answer, like N of 14 is equal to square root of this. 14 is equal to 4 times of this. So if I plug these to each other, so that should be equal to like N of 13 squared. So if I cancel one of these, you get N of 13 is equal to 4, which is the answer to the question 14. So this looks like 4. And then the other one, N of 14 is 4 times that, which is going to be 16. So that looks like our answer. Okay, so 13, or do I do it the other way around? Let me double check. So 13 was like 4, and it says N of 13 is answer problem 13. Oh, I think I just did that. So that would be really bad if I do this actually. Okay, so then like this guy should be like 4, and this guy should be 16. Okay, I hope that was clear. So I'll see you in the next video.